Hello class, this is a video tutorial on the proofs of extension identities part 2. So similar to the other identities, we can merely use them without knowing the following proofs. In this set of proofs, we're looking to prove the product identities. They are called this because we're taking sine A and sine B and multiplying them, hence why it's the product. So we're taking combinations of sine, cos, but not tan. So we're looking at these ones here. Now, a good way to remember these, if we have sine sine, cos cos, it's always using cos. So if it's the same, just because. So same, sine A, sine B, they're both cos. Cos A, cos B, they're both cos. If it's sine A cos B, it's sine. Cos A sine B, they're different. It is also sine. Okay, so that's just one way to help you remember these. So we're looking at proving these identities. So to prove them, we take the pairs of sum or differences, we add or subtract them, then we rearrange. By that we mean the sum and difference trig identities, and we pair them up in the ways that we need to here in the identities. So cos of A minus B minus cos of A plus B, we're looking to prove that one first. So these here are just this right hand side here. So let's go ahead and prove one of them, and you'll see how easy it is to prove the rest. So let's take a look at the first one. Cos of A minus B, taking this one here, A minus B becomes cos A cos B plus sine A sine B, because we're using this identity, minus, and notice how I put that in a big bracket, we take cos of A plus B, cos of A plus B. That is cos A cos B minus sine A sine B. Now from here we can collect like terms. Cos A cos B minus cos A cos B, so those two cancel. And we're left with sine A sine B minus sine A sine B, so two minuses make an addition, hence why we are left with 2 sine A sine B. Therefore we have 2 sine A sine B equaling the initial expression we were looking to prove. So 2 sine A sine B is equal to cos A minus B minus cos A plus B. Divide both sides by 2, and we're left with the identity we're looking for. We can repeat the exact same thing for the other three. I've got them all here. You can pause and give them all a look, but I'm sure you can see that it's not so bad in proving these ones. So once again, we simply take the pairs of trig sum or differences, we expand them like so, rearrange them and collect like terms, and divide both sides by 2 to get the expression we're looking for. And here are all 4 of them. So I hope that gave you a quick insight into the proofs of the product identities of trigonometric identities. Yeah. Hope to see you in the next video. Best of luck.